In the last part of this exam 2 review, we're going to do some systems of equations. And so you can see the directions tell us to use either elimination or substitution. Please make sure that you're paying attention on the test because the test will probably tell you to use one or the other. And if you don't use the method that the test has asked you for, then you may lose points or not get credit. So please make sure you're reading the directions. Since this direction says to use either, I'm going to look at these two and decide which one is better, elimination or substitution. And looking at this, because this x here has a leading coefficient of 1, I'm going to use substitution. I'm going to solve this second equation for x. So I'm going to minus 3y, so x equals 1 minus 3y. And now I'm going to substitute this into x in the other equation, right? So 3, and now instead of x, I'm going to write 1 minus 3y, what x equals to, minus 2y equals negative 7. And now I'm going to solve for y. I'm going to distribute my 3 minus 9y minus 2y equals negative 7. Combine like terms, negative 9 minus 2 is a negative 11y. Minus 3 from both sides. Okay, so I get a negative 11y equals a negative 10. Divide by a negative 11. So y equals 10 over 11 because a negative over a negative becomes a positive. So please remember that whenever you're solving systems of equations, it's always going to be an ordered pair. It's going to be a point where these two lines intersect. So I want to plug in the 10 over 11 is my y part of that answer. If you stopped here, you would not get full credit because you only found half of the answer. What I need to do next is take y and plug it back in to my equation for x. So x equals 1 minus 3 times 10 over 11. Remember fraction operations, you put the 3 over 1, multiply straight across. So I get 1 minus 30 over 11. I'm going to get an LCD of 11, so multiply 1 by 11 over 11, which becomes 11 over 11 minus 30 over 11, which gives me 11 minus 30 is 19 over 11, negative 19 over 11. So my final answer is negative 19 over 11 and 10 over 11, my x and my y. It's a point. And I could take these two and plug them back into both equations, and I should get a true statement for each equation, and that would show me that this was the correct answer. Okay, so this one, we have 2x minus 4y equals 6, minus 3x plus 6y equals negative 9. Since none of these variables have a coefficient of 1, I'm going to choose to use the elimination or addition method, which is where we're going to multiply each of these equations, or sometimes it might be just one of the equations, by a number to cancel out one of the variables. So if you look at the two x's, they already have opposite signs, and they're pretty small numbers, 2 and 3. So 2 times 3 would give me 6. So what I'm going to do is multiply the top one by 3, and the bottom one by 2, okay? So when I do this, I get 6x minus 12y equals 18. For the second one, I get a negative 6x, because I'm distributing this number all the way through, plus 12y equals a negative 18. And now I want to add, with the goal being one of my variables canceling out. So 6x minus 6x would give me 0. Negative 12 plus 12 would give me 0. And 18 minus 18 would give me 0. So this entire equation cancels out. So we get 0 equals 0, which means there is infinitely many solutions. And what it means is these two lines are actually the same line. They actually represent the same line on the graph. So every point on the line is a solution, right? On my math lab, they will have it written something like x comma y such that 2x minus 4y equals 6. And it's actually going to be a choice for you. It'll say infinitely many solutions, and it'll have this set written there for you. For the last one, we have negative 4x plus y equals 8, and 2x minus 1/2 y equals 5. So we still have the choice to use either elimination or substitution. This y has a coefficient of 1, so you could use substitution by solving for y and plugging it in. Or you can use elimination, and that's just kind of a personal preference and what you think will be easier. I'm going to choose to use elimination because I have a fraction here and I want to get rid of that fraction. So if I look at my second one, 2x minus 1/2 y equals 5, what would I multiply by to clear this fraction, right? We've talked about that previously, clearing the fractions, and I would use the LCD, which is 2. If I multiply this equation by 2, what does my leading x coefficient become? 4. Well, my original, the other equation, has a negative 4, so that's going to work out really nice for me. So what I'm going to do is distribute this 2. I'm going to get 4x. What happens here is that 2 times 1/2, negative 1/2, equals a negative 2 over 2, which equals a negative 1. So now I get a negative 1y equals 10. And this is my new second equation. My first equation is still negative 4x plus y equals 8. And now I add 4x minus 4x gives me 0, and negative 1y plus y gives me 0. And then I have 10 plus 8, which gives me 18. And I end with 0 equals 18. And hopefully for you, you say, whoa, 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 this doesn't make sense because 0 doesn't equal 18, right? So this would say, we would say this was not true, right? 0 does not equal 18. So the answer is no solution. Okay? No solution. Or you can write the empty set. It means no solution, right? And what it really means is that these two lines are parallel lines. And there is no point when these two lines are going to intersect because they're parallel lines. So there's no solution. There's no point of intersection between this system because they're parallel lines.